All right, day two was a quicker period. It was on Monday, so we didn't have as much time to cover stuff. So we just really went over how to sketch basic polynomials in factored form. So we talked about what we need to do is find the x-intercepts based on the factors. So if we plug in x equals 2 here, then we get 2 minus 2 is 0, multiplied by 2 minus 4 is negative 2, but 0 times negative 2 is just going to be 0. So it turns out when any of these factors are equal to 0, the whole output is 0, the whole y value is 0, which causes an x-intercept. So we know we have a x-intercept at x equals 2, and we also have one at x equals 4. So we just put those on our axis, and then we know that this is an x squared graph because there's two factors. So the end behavior is up, so we're going to come down, we go through, okay, and these sketches are going to be pretty bad because the axes are small, so it's hard to get precise, but that's okay. So we go through at 2, go through at 4, we get a nice quadratic, right? And again, we're just sketching right now, we're just trying to make sure we have the correct x-intercepts and the correct end behavior. So for this next one, we have an x-intercept at x equals 1, we have an x-intercept at x equals negative 1, and we have an x-intercept at negative 3. Okay, and again, we would be more precise if these graphs were bigger and I wasn't drawing on an iPad, but that's okay. So what we're going to do is we're going to say, oh, this is a cubic function, so it has to have end behavior down, up, and again, cubic because there's 1, 2, 3 factors. So we're just going to loop it through. We're going to start down, okay, and there we go. Okay, there is the sketch of our function, goes through at the right places, has the correct x-intercepts, and if we wanted to get more precise, we could find a y-intercept, which is something we looked at later in the unit. Okay, so this last one is a degree 4, because there's 4 factors. There's an x-intercept at 2, 5, and then negative 2, and then negative 4. Okay, so we know this is degree 4, so it has to have end behavior up, so what ends up happening is it starts up, crosses through, and then there's our sketch. Okay, pretty straightforward. Now, the only other thing we talked about is if you have, let's just look at a couple different options here. Okay, so here we have a polynomial where the x-intercepts are spaced by 2 units each. This is a cubic, so it's going to go down, up, so we're just going to kind of have equally sized lumps between each x-intercept as well as we can, right? But then if we come down here, where look how the gap between these two x-intercepts, right? So between that gap, the output is not 0. It's 0 right here, and it's 0 right here, but it has all this space to be non-zero. So what ends up happening is, well, we start down, we have a nice little lump right there because there's only one unit for it to be non-zero, so it just goes up for a little while. But now it has all this time to come down before it has to come back up. So when we're sketching these, we want to make sure that we account for the fact that the farther apart the x-intercepts are, the further down or up the graph is going to go in between. So again, here they're equally spaced, so they're kind of equal lumps. But here, okay, well, yeah, between negative 7 and negative 8, it like barely goes up, but then between negative 7 and positive 2, it has a lot of time to come down. So when you're sketching, you just want to account for that and make sure that the size of your lumps makes sense. Again, we don't need to have the exact shape of the graph, but we need to make sure that the shape of the graph makes sense, so correct end behavior, comparatively different lumps between x-intercepts, and then going through the x-axis at the right x values.